So next topic is amine, amides, and amino acids. And in this topic, you will learn about azidides as well. So first, what are amines? Naming of the amines. So amine group, basically when NH2 is there attached with a carbon chain, or NH is there attached with two carbon chains, or only N is there and attached with three carbon chain, we call that as amines. So example, you can see the first one, three carbon are there in the chain and attached to NH2 group. So how we can name, there are two ways we can name. If we consider the carbon chain as a branch and main functional group as amine, so we can say propyl because we consider that as a branch. So we can say propyl, and because of NH2 we call amine. So it is propylamine. Or if we consider this carbon chain not as a branch, like as a main chain, main functional group, and NH2, the amine as a branch. So three carbon atoms are there. That's why we call prop. They have a single bond, so we call N. And amine group, NH2 group, is attached with the first carbon, so we'll say it is propane 1 amine. So both ways you can name. It depends on how you're considering. Either you consider one is the common name, the second one is IUPAC name. So IUPAC name, the standard names are like International Unit of Pure and Applied Chemistry System. So the second name is the standard one. This is known as a common name. And for example, if there's another priority functional group is there as well as the amine, then the prefix will be amino. Like, because in this case C double bonded with O and OH, so the main properties of this substance depend on the carboxylic group. So amine is also attached. So 1, 2, and 3 second position amine is attached. That's why amine, we call that as amino, because there are two functional groups and three carbon atoms in the chain. That's why we call that as propanoic acid. Same way, what are secondary amines? If primary amine means when carbon maximum, nitrogen maximum can form 3 bonds. So here, if one carbon chain or one alkyl group is there, we call that as a primary amine. If nitrogen bonded with two carbon chains and one hydrogen is there, we call that as secondary. And if nitrogen is having all the three carbon chains around it, we call that as tertiary amine. So 1 degree, 2 degree, or 3 degree refers to 1 means primary, 2 means secondary, and 3 means tertiary. Same way, example, if this is the secondary amine, so NNH and one carbon is on the right hand side and two carbon atoms on the left, three carbon atoms on the left hand side. First is a common naming. So how we can use a common naming? Common naming, we consider the carbon as a branch carbon chain. So one side we have methyl, another side we have propyl, and we use the alphabetical order. So N-methyl and propyl means N. Basically what this N shows, this N shows that this carbon chain is attached to nitrogen. That's the meaning of this N. So N-methyl because of one carbon, N-propyl because of three carbon, and due to this functional group we call amine. So N-methyl, N-propylamine, that's a common name. But standard naming or IUPAC naming in which we use numbers specifically. So one of the carbon is considered as a branch, the smaller one, and the larger one is considered as a chain. Uh, so main chain, this carbon, which is a smaller carbon number, is refers to branch, and the larger carbon number is refers to main chain. So we have with nitrogen, methyl group is attached to N-methyl. 3 carbon are there, 1, 2, 3. So that's why prop, they have a single bond in. And the first carbon is attached with amine. So it is 1 amine. That's a standard or IUPAC name. And in this case, because we have both identical, so it is N-ethyl and amine. Because both are identical, so one I consider as a branch, another one I will consider as a chain. Is it clear? And the last one is about the tertiary, in which all of the hydrogen are replaced by alkyl groups. So common name, it's NN dimethyl propyl amine. Like this N is for first one, this N is for second one, and then propyl amine. That's a common name. But IUPAC name, so we have 2 methyl groups, smaller one we consider a branch. So N dimethyl, 3 carbon are there, so prop, they have a single bond in, and because first carbon is having an amine group, that's why it is 1 amine. And in this case, we have amine group. Between them, there are 6 carbon atoms, and then nitrogen. So first position and 6th position amines are attached, and there are 6 carbons, so hexane 1,6-diamine. Is it clear, the structure of amines and IUPAC namings?
Yeah.
So just draw the structure and write the name. Because when you draw the structure and write the name, so you will have an idea that what method you are using. Then what are amides? Basically, when C double bonded with O group is attached to amine, we call them as amides. So when C double bonded with O attached with NH2, we call them as amide. How we name amide? And for amide also we have primary amide, secondary amide, and tertiary amide. What is the meaning of primary, secondary, and tertiary? Because this is the amide group, C double bonded with O and N. So the nitrogen, if 2 hydrogen are attached to nitrogen, so in this case we call that as a primary amide. But if 2 alkyl or 2 carbon chains are there, then we call that as secondary. If all of the hydrogen are replaced by carbon chains, then we call that as tertiary. So how we name this? So instead of amine, we will add amide to the stem name. Example, you can see here 2 carbon atoms. So 2 carbon atoms we'll call eth. The bond between them is a single N, and Because of this functional group, we call amide. So secondary and tertiary are differently, like example, if two carbon chains are there, in secondary, three are there, then tertiary. So how we name this? Okay, this is the main chain and this one is a branch. So N-methyl means with nitrogen, a methyl or one carbon is attached. That's why N-methyl. Three carbon in the main chain, so it's called prop. Single bond between them in, and because of the functional group, we call that as amide. Same way, if two carbons are attached, so N dimethyl propane amide. But in this case, the branch, there is for a main chain, there is also a direct branch is there. So N position, and then there is also the second position, trimethyl, because three methyl branches are there, and the main chain is having three carbons, so it will be propane amide. So this is how we name primary, secondary, and tertiary. Is it clear how we name primary, secondary, and tertiary amides? Any doubt in this? Then the simple properties of these amines. So amines have the characteristic fishy smell, and small amines can form a hydrogen bond with water. Therefore, they can dissolve readily in water, because if they have the identical or same type of bonding, the substance are miscible or can dissolve. Because there is a lone pair hydrogen attached to most electronegative elements such as oxygen, fluorine, or nitrogen, it tends to form a hydrogen bond. Because nitrogen is more electronegative than hydrogen, so it appears that the shared pair of electron is almost transferred towards the nitrogen. So it will create a partial negative on nitrogen and partial positive on hydrogen. And this partial positive hydrogen is attracted towards the lone pair of nitrogen. So we call this as hydrogen bond. Then the base properties. So aliphatic means the straight chain or even a branch, but not a cyclic. Aliphatic amines act as a Bronsted or Lorry-Bronsted base because they have a lone pair on nitrogen, and that lone pair tend to accept proton. When something tend to accept proton, we call that as a base. Like example, if you have aliphatic amine such as methylamine, so in case of this methylamine, nitrogen is having a lone pair. So this lone pair of nitrogen has a tendency to accept the proton. So if something having a tendency to accept proton, it will act like a base or alkali. Then if we have a primary amines, example, primary aliphatic amines are stronger base than of ammonia. And alkyl groups are known as electron releasing groups. So they push the electron towards the nitrogen, so make it more stronger base. So if a question is which is stronger alkali, aliphatic amine or ammonia, so aliphatic amines are stronger alkali as compared to that of ammonia. So what is the reason? Because these methyl groups, these alkyl groups, they are electron releasing group. So when we say something is electron releasing group, it has tendency to shift the electron. So nitrogen, hydrogen, and there's a bond between carbon and nitrogen. But alkyl groups are electron releasing, so they have tendency to shift the electron pair towards the nitrogen. So nitrogen will become more negative. So now it has greater tendency to accept proton. So it has greater tendency to accept protons. So it is stronger alkali aliphatic amines as compared to normal ammonia. And then when we compare the secondary amines, they are stronger base as compared to primary because they have more alkyl. So greater the, like if I have a primary alkyl amine, this is primary alkyl amine, and if we have secondary alkyl amine, so secondary alkyl amines are strong base as compared to, or strong alkalis as compared to primary. Why? This is a nitrogen group because alkyl groups or carbon chain, they are electron releasing group. So they make this nitrogen negative. But because two alkyl groups are there, so they make this nitrogen more negative, so it can attract the proton. If something can attract proton or accept proton, it will be alkali. And when we compare the tendency of aromatic amine means amine group attached to a benzene ring, we call aromatic amines. So primary aromatic amines such as phenylamine do not form a base because what happened? This lone pair is there of electron of is actually added to the benzene ring, or it is increasing the electron density of a benzene ring, which make it less tendency to accept the proton. So there is a lone pair and they also have the electron pair. So this lone pair is actually shifted more towards the benzene ring, so which make it less negative. It is less negative, it cannot accept the protons. So when we compare in if we summarize, when we compare, so aliphatic amines are stronger base than ammonia, and ammonia is a stronger base than aromatic amines. Is it clear?
Yeah.
So they ask these reasons. You have to give a reason why aliphatic amines are acting like a base, then why aliphatic amines are stronger base than ammonia, and then why secondary amines are stronger base than primary amines. So copy this part, the characteristic of or properties of amines. So reactions of amines, because as we know amines, aliphatic amines, they can act like a base. So acid-base reaction can occur. So amine as a base react with acid to form ammonium salt. You can see here if methylamine mixed with hydrochloric acid, it will form methyl ammonium chloride. And addition of sodium hydroxide to ammonium salt will convert back them into amine. Same thing if we have sulfuric acid and ethylamine. So, methylamine with sulfuric acid. So it will give methyl ammonium sulfate. The ionic salt formed in the reaction is a compound which is soluble, and phenylamine is not very soluble in water, but phenyl ammonium chloride is soluble. This this one is not relatively soluble, but when it form a salt, it will dissolve or it will be soluble. Then making a basic buffer from amines. But what is a buffer solution? As we know, a solution which resists the change in pH, we call that solution as a buffer solution. Normally, buffer solutions are weak acid and their salts, or weak alkalis or their salt. So as we know, alkyl amines are alkali or basic. So methylamine plus methyl ammonium chloride, or ethylamine plus ethyl ammonium chloride, or ammonia plus ammonium chloride, all these are examples of buffer. So basic buffer can be made by combining a weak base